In this video, we'll cover the basics of Emonitor Alarms. Emonitor offers a variety of fully customizable data views, but the most common view for viewing our current alarm states is called the Alarm Panel. So to get there, we'll go to the View menu, and we'll pick Alarm Panel. From here, we can see a variety of things. First of all, notice the highlighted bands. The colored highlights indicate acknowledged alarms versus unacknowledged alarms. And you also see the severity indicator dots. The acknowledgements are designed to allow multiple user systems to signal to other users whether or not alarms have been processed or not. To acknowledge an alarm, we simply right-click it and choose Acknowledge Alarm Status from the right-click menu. After we've done this, you'll notice the highlighted band goes away, and the hierarchy item is now presented in its natural white color with no highlight. But the severity indicator dot maintains its alarm condition, so long as the condition is satisfied. We can clear the alarm status if we have some reason to need to do that by right-clicking on the hierarchy item and saying Clear Current Alarm Status. And this will reset the severity indicator dot as well. The level of the hierarchy that we perform this action on determines which items will be processed. So the higher up the hierarchy, we can acknowledge alarm status, and the highlighted bands will disappear for all of the items underneath that piece of hierarchy. Notice again that the severity indicator dots remain. The alarm severity colors are fully customizable. Under the Setup Options Alarm Severity menu, we have a variety of options here to define what the severity level is, up to 10 levels. And we can assign any level a customized description, and we can assign a customized indicator color dot. If we open up a trend plot by right-clicking on a measurement saying Show Data, by default, Emonitor doesn't actually show you the alarm thresholds on the initial plot. Instead, you have to double-click in one of the margins to open the plot options, click on the Alarms tab, and then opt to select one or more alarms and show alarms, and then apply. I'm undoing that process here. This is what the trend plot looks like by default. And the reason we do this is that Emonitor does not limit how many alarms you might define. So we leave it up to the user to decide how many of those alarms, or if any, we want to activate and actively show on a plot by default. For example, I wanted to choose warning and critical. I can say Show Alarms and apply. Now it'll show me my warning and critical alarms. If this is the configuration that I would like to look at by default, I can set that by going to Plot, Save as Default. And from this point, anytime I open up a trend plot, it will show me those warning and critical alarms if they're defined. So let's take a look at a spectrum plot. Again, by default, we don't show the alarms. We can easily turn them on. Double-click in the plot margin, open up the plot options, select the Alarm tab, and we can use either the Shift key or the Control key to pick one or more alarm conditions that we want to display. Notice there are two types. This happens to be the band alarm, where we are defining an upper and lower threshold for a frequency band, looking for known fault frequencies. There's also a spectrum alarm type, which effectively draws an envelope around the entire frequency range using the offsets that we specify. This is a particularly helpful alarm type for finding those conditions that we did not expect. Again, I'll pick band alarm, warning, and critical, and I'll set this as my default for the spectrum. plot type. So how does Emonitor know what the alarms should be? We define these in the Alarms view. So going to the View menu and picking Alarms, we see a very similar data view arrangement, except instead of the Archive Data pane at the bottom, we have the Alarm pane at the bottom. So if we pick a measurement, we can see that we have one or more alarms defined for each measurement. Of course, you can choose not to define any alarms as well. There are a variety of alarm types or alarm methods available for each data type. For the magnitude data type, it might be helpful if I resize the pane here so we can see the entire drop-down. Under the alarm method, if I double-click an empty cell, I can pick from a variety of alarm methods available here. Mag constant, mag in a window, the peak, magnitude, mag stat, stat indicator, baseline. There's also a rate of change, percent change. A big difference between the stat and the stat indicator, these are both statistically derived alarms. The stat alarm method requires us to update statistics manually for a defined list of measurements. The stat indicator updates that data on the fly whenever new data comes into the database. Looking at a mag constant alarm, you can see we can define above or below. We can add a constant value of 0.25. But previously you saw when I pulled it up, it said high alarm 1. These are called category variables. And these are helpful when we have many machines that share the same alarm characteristics. I can define these by using the machine category. In this case, I've got a standard machine category. These are fully customizable. And what we're looking at here is anything that affects amplitude, which would be your units, your filter, and the signal detection. So in this case, I have peak signal detection on this magnitude measurement. It's inches per second, and it uses no filter. So if I look at my machine category, I want to find a combination of units, filter, and signal detection that matches that measurement. So this one shows G's, which is not the unit we're in. We're looking for inches per second. So we'll scroll through the next unit until we see inches per second, no filter, and peak signal detection. Finally, we found one. And here, high alarm 1 shows 0.25. So when I reference that high alarm 1 category variable for this measurement on this alarm, 0.25 is the value that it will apply. If I'm getting nuisance alarms, for example, on this particular measurement over a variety of my machines that share this machine category, rather than editing that alarm threshold on every single measurement manually, I simply edit it in the machine category for the appropriate units configuration, and that threshold applies to all measurements using that category variable. Looking at the stat indicator, you can see we have similar above or below. Although when we're calculating statistics, we need to indicate whether or not we're going to include all samples or a specific number of samples in the calculation. I can define a percent from average and a sigma standard deviation from average. And since it's a statistical indicator alarm, the statistical threshold is calculated is updated anytime new data is inserted in the system. And this is in comparison to the mag stat, which gives us basically the same configuration options, only it does not update the statistical alarm calculation automatically. It does it manually. And to do that, we first need to tag the necessary measurements. So we would pick one or more measurements and tag them from the toolbar. And then we can go to Tools, Generate Alarm Statistics, and it'll calculate the new alarm thresholds based on the current data. Looking at the percent change is fairly straightforward. We have a percent of change, which can be a category variable or a static value. Magnitude baseline alarm. We first have to make sure that we have a baseline defined, which is extremely simple to do. If we were to go to our data history view, for example, we can see in the archive data pane there is only one measurement here, sample, that is listed as baseline. We can change that by simply double-clicking and assigning baseline to a new measurement. So this would be typically our known good measurement. And then we calculate based on the amplitude from that particular designated baseline sample. If for some reason there's data that you do not want included in your statistical calculations, you can also use the storage flag column to set that particular sample to no stat, in which case it will be omitted from the statistical calculations. If we go back to our alarms view, select a spectrum measurement, we can see that looking at a band type, band constant, we're using a category band set of high alarm 1. So again, we go to our category variable, our machine category, and we look up the particular combination of units, filter, and signal detection, and see what those category variables are. So on this spreadsheet on the right-hand side, these are our band variables that would apply. Now you're not locked into using this specific default band setup. You do have the option, if we go back in here, to set a custom band. You can pull it from the drop-down list. Here we only have 2 available. We can define those quite easily from this dialog box. However, if we want to create new custom band sets, we go to Setup, Band Sets. And from here we can click the New key and we can define as many new band sets as we like. And these will appear in the drop-down list under the alarm configuration. If we look at a few other types here, there's a band percent change, pretty straightforward. Let's take a look at a spectrum baseline. So here, the spectrum alarm again is an enveloping alarm. So we can define whether it's a constant width or a percentage width. We can define our low frequency cutoff and the percent from a baseline measurement. And again, we have our stat and stat indicator statistical alarms, just like we do with the magnitude data types. If we look at some of the other types of alarms that are available, double click in our empty cell in the alarm method column. We also have our baseline percent change, rate of change. Then we have our spec alarms as well, same kind of things. So 2 different alarm types. Now, looking at our alarm panel once again, how do we update alarms? Well, Emonitor gives you a couple ways to do this. We can simply right-click on a machine, and we can come down to Process, and then Update Alarm Severities. And Emonitor will update the alarm severity states for that particular machine. When you run it this way, you can continue to work in the background until the dialog box pops up indicating that the process is complete. Notice that the severity indicator dot is now once again in the critical red. You can run this process at any level in the hierarchy, and all child items to that hierarchy item will be processed as well. So if we clear the alarm status from the main area, I'll show you another method here. I'm going to tag that main area and then save that as my current list with a saved name, and I'll just call it main. Now I can run an alarm update on the entire main area referencing that saved list from an external utility in the Emonitor utilities folder, and this is called Severity Updater. This is an external utility that runs in the background separate from the main application. So I'll choose main, and I'll opt to reset the acknowledge status, and I'll choose update. And I can continue working in Emonitor while this is running. This can also be scheduled from a command line with a simple batch file referencing that same saved list and run on a schedule using Windows scheduled tasks. If I refresh with an F5 here, you'll see that the process did update the alarms and also the alarm acknowledgements. If I go back to my severity updater here, I can hit the F1 key for help, and you can see that I can also look up the command line parameters as well. So we'll close the severity status updater. Let's take a look at one of our plot views now that we've got our alarms updated. Opening up a common vibe analysis view. This is a standard plot view that's totally customizable. We're going to double click on our margin in our spectrum plot, pick some alarms on the bands and add them. You can see they show up in our data view, just as they do in a single spectrum plot. Thanks for watching.